In this video, we will see more about the matrix part of the Classilist interface. So, this matrix part gives us the traditional confusion matrix. Confusion matrix is we have the actual classes here in the vertical scale and the predicted classes here in the horizontal scale. So, as we know that we have so many of the true positives, so this is the darkest, these are the diagonal has the darkest squares, darkest sections. So we can hover over these squares to know more about them. Like this is the actual classes L5 and predictors is L2. There are no instances that belong to this category, that's why the count is 0. And if you hover over this, the actual class is L9, the predicted class is L3, and number of such instances is 347. So this is how we can see which two classes are confused upon, or which two classes need to be taken care of in the classification algorithm, and this is how this confusion matrix contributes to the analysis of classifiers. Now what we have two more features in this. Firstly, as we know that this diagonal takes up much of the scale space, that is current scale is the color scale, where lighter colors indicate lower counts and darker colors indicate higher the counts. Like here we have for count 127 we have this lighter color, and for count 1059, that is 1059 counts, 59 instances, we have this darkest color. So while we don't if we don't want to analyze the diagonals, because these are the true positives and don't need to be analyzed so frequently, we can just turn off the diagonals, and what we can see is the scale resets itself. Now this is the same section that we saw. It was a little bit lighter earlier, and now after turning off the diagonals, it is somewhat darker, and that's the main purpose of this show diagonal and hide diagonal box. The other feature that this confusion matrix has is the we can change its scale. Currently it has this all the sections have same sizes, and their intensity is defined by their color. And now we can change the size, we can change the scale. Now all the boxes have the same color, but the counts are defined by their size. We can see this is the size, this size corresponds to 1059 instances, and this size corresponds to 127 instances. So here also, as we can say see that these diagonals take up a lot of space, a lot of scale, so we can turn off the diagonals, and what we now see is a better confusion matrix, where we can see all these significant parts that we want to improve and analyze in our classification algorithms. And this is the purpose of these two options, where we can get better insights even from the traditional confusion matrix. And also yes, the most awesome feature of this confusion matrix is they can create selections. Firstly, we will reset the scales to see what actually these selections can do. So now this corresponds to the 347 instances that were actually L9, actually belong to L9, but they were predicted as L3. So we will click onto this, and we can see where these instances lie in all the classes. So we scroll down, and in all the classes, almost all the classes, we have them in true negatives. It's fine. In L3 they are false positives, as we know that they were predicted as L3, so they will be in the false positives, and they are in the false negatives in L9, as they actually belong to L9. And similarly we can see it in summary. This is L9, this is L3 they are false positives, and L9 they are false negatives. This is the use of the confusion matrix and selections generated by the confusion matrix. Also we can also like we have selected this data, this set of data, we can also see the features where we went wrong, like 85, it's almost comparable, almost it doesn't, the median of complete dataset and median of the selected dataset are same, but 81, so we need to focus on 81 if we want to improve the classification of this section of data.